2.4, the chain rule, day 2. Yesterday we looked at the chain rule, which helped us deal with problems where we had a function inside of a function. Let's use the chain rule and apply it to this problem. All right, first we need to rewrite this problem to get rid of the radical, and I'm going to get rid of the fraction so I don't have to use the quotient rule, which is a lot longer than the product rule. So I'm going to rewrite this as x times x squared plus 4 to the negative 1/3. Then I can apply the product rule because I have a multiplication of two functions. So I will go f prime of x equals first times the derivative of the second. Now our second function is what we call a composite function because there's a function inside of a function. And with the chain rule, to do the composite function, we need to recognize the inside function, which is x squared plus 4, and take the derivative of the outside function. So the derivative of the outside function, which is something to the negative 1/3, we'll apply the power rule. We get negative 1/3 times that something to the subtract 1, negative 4/3. Well, the inside function is x squared plus 4, and now we need to multiply by the derivative of the inside function, which is 2x, plus the second function times the derivative of the first, which is 1. All right, that is the chain rule. Now there's some simplification that could be done here, but we're going to skip that for now. Find the derivative of the function at the indicated point. You can use a graphing utility to verify a result, and we will do that. All right, so let's first rewrite our function to x to the negative 1 plus cosine 1/2 of x. All right, and we will find our derivative with respect to x. X to the negative 1 is negative x to the negative 2. And then here we have a composite function. The inside function is cosine. The outside function is something to the 1/2 power. So we'll start with the derivative of something to the 1/2 power, which is 1/2 times something to the negative 1/2 power. And then multiply that times the derivative of cosine, which is negative sine. All right, so let's plug in pi over 2. And we get negative 1 over pi over 2 squared plus 1/2 cosine of pi over 2 is 0. And since that puts this on the bottom, this is undefined. Which means it has a vertical tangent. All right, so let's graph this and take a look. Our function is 1 over x plus the square root of the cosine of x and we'll zoom to a trig window here, number 7. And if we trace it to pi over 2, you can see it's starting to get really steep, so steep it did not connect the lines. All right. Let's look at this and calculate it. Second calc, we can go down to the 6th option and find the derivative at pi over 2. It says non-real answer. Again, that's because here we divided by 0. Let's look at the chain rule in another rule. What if we start with something like this? Right? How do we find the derivative off of tables? Well, you apply the same rules. Here we have a function inside of another function. Right? That's chain rule. Right? To apply the chain rule, you take the derivative of the outside, so in this case it would be f prime of, leave the inside alone, 2 times g of x, and then multiply by the derivative of the inside. And the derivative of 2 times the g of x, use the constant multiple rule, that's 2 times g prime of x. And then here all we got to do is plug in 4. So this is f prime of 2 times g of 4 times 2 times g prime of 4. Then we just read it off the chart. G of 4 is 2. So we got f prime of 2 times 2, which is 4. Then 2 times g prime of 4 is 3. Right, f prime of 4 is 4. This is 4 times 6, which is 24. So if you're given a chart, you're going to apply the same rules. All right, let's try another example of this. All right, k of x equals g of f of x minus f of x squared minus 1. All right, same thing. Apply the chain rule. Here we have f inside of g. So we're going to take the derivative of the outside first. So we got g prime of f of x multiplied by the derivative of the inside, which is f prime of x. Here we have another function, and here we have f of x squared minus 1. Our inside function is x squared minus 1, and our outside function is f. Same thing. Take the derivative of the outside, leaving the inside alone, then multiply that times the derivative of the inside, in this case 2x. And then just plug in 2. So here we got g prime of f of 2 times f prime of 2 minus f prime of 2 squared minus 1, which is 3, times 2 times 2, which is 4. All right, as we continue, f of 2 is 0. So we got g prime of 0. F prime of 2 is 5. So g prime is 0 times 5 minus f prime of 3, which is 2 times 4. G prime of 0 is 0. So this whole thing will be 0 minus 8, which is negative 8. All right, so let's look at another table example. This one, let's rewrite as g of 5 minus x to the 1/2. And we got a level of 3 functions here. We got the square root, we've got g, and we've got 5 minus x. Well, it's the same thing. We've got to take them in levels. We'll first do the outside level, which is 1/2 times g of 5 minus x to the negative 1/2 as we subtract 1. Then we'll multiply that times the next level, g prime of 5 minus x. And then we'll go inside even further. We'll take that times negative 1. And then it's simply a matter of substitute and simplify. So m prime of 3 will be 1/2. I'm going to rewrite this a little bit bigger because we have a negative 1/2. So that'll be on the bottom. G of 5 minus 3 is 2 times g prime of 5 minus 3, which is 2 times negative 1. All right, g of 2 is 3. So this is 1 over 2 square root of 3. G prime of 2 is 4. So that's times 4 times -1. And if we simplify that, which isn't totally necessary, but I'm going to do it anyway, it's -2 over the square root of 3. All right, so in conclusion, when you have a function inside a function, you're going to do the outside function first times the derivative of the inside. G of x, and if we have 3 levels, f of h of k, we'll start at the outside, f prime of h of k, work into h prime of k, and work into k. Working outside to inside to find the derivative of a composite function.